All right, here are the solutions to the 3.1 activity. Hopefully my daughter's ballet class in the other room doesn't come through too much here on this recording. Okay, so the first question says, find the critical values of the following functions, and there's three functions we're asked to think about. So the critical values are going to occur when the function is equal to 0, or when when the derivative is equal to 0, or when the derivative is undefined. So this first function, h of x, is x minus 1 divided by x squared plus 4. So we use the quotient rule to take the derivative. Simplify in the numerator, we get h prime of x is negative x squared plus 2x plus 4 over x squared plus 4 squared. The denominator is always positive here, so we know that this derivative is defined everywhere. So the only time it's going to be equal to 0 is when the numerator is equal to 0. So we have to solve this here to find our critical values. We can factor out a negative. That's the opposite of x squared minus 2x minus 4, which unfortunately is not factorable. So we have to rely on the quadratic equation over here on the right. We rely on the quadratic equation. We get 1 plus or minus the square root of 5. And then we have two critical numbers, x being 1 plus the square root of 5 and 1 minus the square root of 5. Okay, the second function is f of theta is 4 theta minus tangent theta. Take the derivative of that function, f prime of theta is 4 minus secant squared theta. And so now again we want to find where f prime of theta is equal to 0. That's 4 minus secant squared. And that is secant squared when secant squared of theta is 4, and that's going to be when cosine of theta is equal to 1/2. Okay, but there's something else to think about here. So there are some of the critical values, but have we found them all in this case? And let's think about coming up here and rewriting f prime of theta. It's 4 minus 1 over cosine of theta squared. So it is going to be undefined, in fact, when cosine of theta is equal to 0. Okay, so we have to be careful with these trig situations. So these are the critical values for f of theta when f prime is equal to 0. But f prime is undefined, so we get other critical values when cosine is equal to 0. So theta is, let's see, cosine is 0 first at pi over 2, then again at 3 pi over 2, 5 pi over 2, etc. It's 0 at negative pi over 2, negative 3 pi over 2, etc. So those are the critical values we get from when f prime is undefined. So these are critical numbers also, and these are the critical numbers from f prime of theta being undefined. So this function actually has a lot of critical numbers where the derivative is either 0 or undefined. Okay, here's the last example. I left this one to work out because of the fractional exponents sometimes cause a bit of a challenge. So let's go ahead and find g prime. So g prime of t is 1/3 times 4 minus t squared. We go to 1 less power is the negative 2/3. We need the chain rule though, so the derivative of 4 minus t squared is negative 2t. Okay, let's rewrite a g prime with positive exponents. Let's see, I think we get a negative 2t in the numerator and a 3 times 4 minus t squared to the 2/3 in the denominator. Okay, this one isn't so bad with the negative exponents. With the fractional exponents. When is g prime going to be undefined? Well, g prime is going to be undefined when you get a 0 in the denominator. And the only way that could happen is if 4 minus t squared is equal to 0. So g prime of t is undefined when 4 minus t squared is equal to 0. And that's going to happen when t is plus or minus 2. G prime of t is equal to 0 Well, this ratio will only be equal to 0 when the numerator is equal to 0. So that's going to happen when negative 2t is equal to 0 or t equals 0. All right, so that gives us 3 critical numbers. So the critical numbers for g of t in this case are x equals negative 2, 0, and positive 2. Okay, the next question says, find the maximum and minimum values of this rational function x divided by x squared minus x plus 1 on the interval from negative 2 to 2. Okay, so 2 steps in finding the maximum and minimums. First is to find the critical values. Next is to test those critical values and see which one gives the largest output. So first I took the derivative using the quotient rule again. And then I simplified that numerator. So we need to find when f prime of x is equal to 0 and when f prime of x is undefined. So f prime of x is going to be equal to 0 right here when the numerator of that ratio is equal to 0, and that's going to happen when x is plus or minus 1. And it's going to be undefined when the denominator equals 0, but x squared minus x plus 1 in fact is not equal to 0 if you tried to factor it or use the quadratic equation. You could see that, so that does not happen. And so we've been asked to find the maximum and minimum values on this interval. So that means to do that, we need to test the critical values and the endpoints of the interval. So we got 2 critical values, 2 endpoints. So we come over here, we can draw a table of values. We need to test the inputs of negative 2, negative 1, 1, and 2. We put those up into the function f of x because we're asking about the outputs of this function. When is it largest or smallest? And we see what we get there as the outputs. And so the maximum occurs when we are at a y value of 1, and that's the point 1 comma 1. And a minimum occurs at negative 1/3, which is at the point negative 1 comma negative 1/3. Okay, number 3 says find the maximum value of x cubed times 1 minus x cubed. Okay, we could try to cube that thing out, distribute, and just have a polynomial with 4 terms and take the derivative, or we could use the product rule to take the derivative. So we need to find the critical values. I've used the product rule here to take the derivative. So we get x cubed times the derivative of 1 minus x cubed. We have to use the chain rule there. That's where the negative 1 comes from, plus 3x squared times 1 minus x cubed. So the chain rule happened within the product rule. Okay, so this is going to happen often. We're going to see situations like this, and I found that students' first instinct always is just to multiply this thing out and then try to solve, but it actually is a lot more difficult to do that. So here we can actually factor something out. We see both of these terms. This term has this first term has a 3x squared, and this one has a 3x cubed. So they definitely both share a 3x squared. This one has a 1 minus x to the third, and this has a 1 minus x to the second. So they also share a 1 minus x to the second. And then now I can see what's left. If I look at this first term, oops, let me fix that parenthesis there. Sorry about that. 1 minus x to the second. If I look at this first term, I factored out a 3x squared and a 1 minus x to the second, but I had a 1 minus x cubed, so I still have a 1 minus x in the first term. Then I have the subtraction sign between them, and I look at the second term. I would have factored out a 1 minus x squared. I got all of that, but I got 3x squared here. I had 3x cubed, so I'm missing an x. So if you redistribute that, you should get exactly f prime above, and so then we can simplify f prime. It looks like 3x squared times 1 minus x quantity squared times 1 minus x minus x, 1 minus 2x. So now our critical values are going to come from when each of those pieces are equal to 0. Okay, so we want to set 3x squared times 1 minus x squared times 1 minus 2x equal to 0 to find our critical values. So that's going to happen when 3x squared, sorry about that, equals 0, which is when x equals 0. 1 minus x squared equals 0, that's when 1 minus x equals 0, or x equals 1. And finally, when 1 minus 2x equals 0, and that's going to be when x equals 1/2. Okay, so those are the options for maximum value of this function. And so let's see where that maximum occurs. X, f of x. And we need to check our three critical values, 0, 1/2, and 1. And at 0, what do we get? We get 0 cubed times 1 minus 0 cubed, which is 0. At 1/2, we get 1/2 cubed times 1 minus 1/2 cubed. Sorry, 1/2 cubed. That looks like 1/2 cubed times 1/2 cubed. So that looks like 1/8 times 1/8, or 1/64. And at 1, we get 1 cubed times 1 minus 1 cubed, or 0. Okay, we ask ourselves which one of those is largest. And that largest output here is 1/64. And so we would say that there's a maximum at 1/2, 1/64. Okay, there are the activities to the 3.1 solution. See if you can use those to help work through the homework in the textbook.